Breaking news from the frontiers of space. A cosmic event has been detected by the ATLAS telescope that could trigger an unprecedented chain of disturbances across the universe. On September 28, 2025, ATLAS, a groundbreaking space observatory located on the outskirts of Earth's atmosphere, picked up a signal unlike anything it has recorded before. This anomaly, discovered at an astounding distance of 14 billion light-years, is not merely a transient flicker in space. It's something far more profound, a disturbance whose implications could ripple throughout the very fabric of space-time itself. ATLAS, which typically scans the skies for signs of supernovae and cosmic events, has now alerted scientists to a peculiar disturbance that has the potential to set off a cascade of chaos across space. For over a decade, ATLAS has been a sentinel in space, its detectors scanning the cosmos for faint signals of galactic births, deaths, and every phenomenon in between. But what it has uncovered now, a burst of unknown energy, could be something far more dangerous. Some speculate this could be the first sign of a galactic event capable of disturbing the stability of the universe, leaving humanity to question the very laws of physics. The discovery has raised immediate concerns. This unprecedented signal, still being analysed, appears to have originated from a previously uncharted region of the cosmos, far beyond our immediate cosmic neighbourhood. Scientists are scrambling to decipher what this could mean for the future. Could it be a precursor to a cosmic collapse? Or perhaps the early stages of an interstellar disruption that could shift the dynamics of entire galaxies? As this event unfolds, it is crucial to understand that the very nature of the disturbance remains speculative. What is known, however, is that the energy released from this anomaly is unlike any known cosmic phenomenon. It seems to challenge every rule we thought we knew about space and time. ATLAS has provided us with initial data, but the real question is, what comes next? How will this discovery change everything we know about the universe? In this report, we will explore the full extent of this event, piecing together the fragments of this cosmic mystery. From the moment the signal was detected to the potential dangers that may be unfolding, we will delve into the ramifications of this space chaos and what scientists around the world are doing to understand it. Stay tuned as we investigate a phenomenon that could redefine our understanding of the cosmos forever. At first glance, the discovery by ATLAS appeared to be a typical cosmic event, a sudden burst of radiation from a distant galaxy, one of countless signals that are routinely analysed by astronomers around the world. However, a deeper investigation revealed something startling. The signal was unlike any previously recorded. It wasn't just a sudden burst, nor was it a mere anomaly. It was a sudden and dramatic brightening of the cosmic sky, one that began to intensify at a rate never before observed in space. The burst of energy emitted from the heart of a distant galaxy, some 14 billion light-years away, was initially thought to be a typical supernova or a gamma-ray burst. But as the signal continued to grow brighter, ATLAS deep space sensors began to detect irregularities. Unlike a supernova, which typically fades after a period of weeks or months, this brightening continued to intensify, expanding and fluctuating in ways that defied standard expectations. The wavelength of the emitted radiation was also strange, a spectrum that did not match any known type of stellar or galactic event. For hours, the ATLAS team observed this unprecedented flare, and their first hypothesis was that it might be a new form of stellar explosion, something previously theorized but never confirmed. However, as more data came in, it became clear that this event was far more complex. The intensity of the flare didn't simply imply a stellar event, it indicated a release of energy so concentrated that it could only be the result of an interaction at the very fabric of space-time itself. As astronomers and physicists reviewed the data, they noted that the event was not confined to one specific wavelength, but was instead a multifaceted burst, spreading across the electromagnetic spectrum. The light from this event wasn't just visible, it reached into the infrared, ultraviolet, and even the radio spectrum. It was as though the fabric of space was unravelling itself, transmitting waves of energy in all directions. The implications were profound. Such an intense and sustained brightening could only mean that the event was somehow tapping into a previously unexplored energy source, perhaps something more fundamental to the structure of space itself. If this burst of energy was indeed tied to an instability within the structure of the cosmos, the questions became even more pressing. What is causing this brightening, and how far will the effects spread? Scientists began to speculate about the possibility that this event could be tied to something even more destabilizing, a rupture in the stability of space-time. If such a rupture were indeed occurring, it could explain the erratic behavior of the signal. At first, it seemed as though the event was confined to the specific galaxy it originated from, but as the brightening continued, it began to affect neighbouring galaxies. The very nature of the event seemed to defy our previous understanding of cosmic forces. It's not entirely clear whether this brightening is the result of a natural process we have yet to fully understand, or if it is a sign of something far more unsettling. As the event continues to unfold, scientists are now scrambling to model the behavior of space-time in this region of the cosmos. Could it be that something as fundamental as the very fabric of space-time is becoming unstable? As the Atlas team continues to monitor the event, astronomers are now faced with a challenge, understanding not only what is happening at the core of this burst, but also its far-reaching implications for the rest of the universe. Could this brightening be the precursor to a much larger far-reaching disturbance? Or is it an isolated incident, a momentary aberration in the vastness of space? With each passing hour, new data comes in, but rather than providing clarity, it only raises more questions. And as we continue to study the signal, one thing is becoming increasingly clear. This event is unlike anything we've seen before, and it could very well lead us down an entirely new path of understanding the universe. What is certain, however, is that the universe is trying to tell us something far beyond what we've ever known. Stay with us as we explore the next phase of this cosmic crisis. The events unfolding may just be the beginning of a new era of space exploration, one that will test the limits of our knowledge and challenge our understanding of the very universe itself. As the mysterious brightening continued to escalate, the ATL-AS telescope's data began to show a more disturbing pattern. Initially considered a relatively isolated cosmic anomaly, this event quickly evolved into a massive disturbance that appeared to spread across vast distances in space. Scientists first thought it was confined to a single galaxy, but as data came in, it became clear that this event was far more expansive than anyone had imagined. The signals from this burst began to reach other galaxies, distorting cosmic structures at a rate far beyond what was thought possible, and faster than the speed of light should allow. The disturbance, it seemed, was not simply a fluctuation in light or energy, but a structural disruption in space itself. Atlas researchers noticed ripples spreading outward from the source, waves of energy that were causing irregularities in the behavior of nearby stars and galaxies. These disturbances were bending light, altering gravitational fields, and even creating microvariations in space-time. The very laws of physics were being bent in real time, and the implications of this were profound. To understand the scale of the phenomenon, scientists had to first consider the magnitude of the energy released. This wasn't just a localized burst, it was more like a cosmic wave, affecting everything it touched. The strength of these waves began to suggest that the disturbance was much more than a burst of energy. It was as if space itself was responding to an unknown force, one never before detected. In trying to comprehend the scope of the event, physicists turned to the concept of gravitational waves, ripples in space-time first theorized by Einstein and detected only in recent years. Could this event be creating a version of these waves, but on a much larger scale? The problem, however, was that the disturbances recorded by ATLAS did not align with known gravitational wave behavior. Instead of a smooth, predictable ripple, the signals from this burst were erratic, chaotic, and irregular, an instability unlike anything previously observed in the universe. As the situation deepened, scientists considered a far more troubling possibility. The burst might have triggered a disruption in the very properties of space-time itself. This scenario, once considered only in theoretical models, suggested that space could become unstable. This was no longer just a cosmic burst. It could be the unravelling of the universe's very structure. If this disturbance was capable of altering space-time in such a way that the fundamental laws of physics broke down, what would become of the galaxies, stars, and planets within the affected regions? Could this lead to the collapse of entire galactic systems? Or, more alarmingly, could the instability spread across even greater distances, destabilizing gravity, light, and matter throughout the cosmos? Adding to the concern, new data revealed that the disturbance was causing strange behaviours in black holes, those enigmatic cosmic objects that are known to bend space-time. Their event horizons were expanding and contracting in ways never before seen. The intense gravitational forces surrounding these black holes were likely being affected by the space-time anomaly, causing waves that could propagate across vast distances, bending the orbits of stars and altering their paths. Could it be that these black holes, once thought to be stable, were now becoming instruments of cosmic chaos? If these black holes were destabilized, their immense gravitational pull could warp distant regions of space, displacing entire solar systems and galaxies. The implications of such shifts in gravitational dynamics were both profound and alarming. The Atlas team, now on high alert, was collaborating with other observatories and space agencies to develop models to predict the disturbance's spread. Yet every model they ran seemed to defy expectations. Each new data point revealed unforeseen consequences, further complicating their understanding of the event. Could this be part of a larger cosmic process? Could this disturbance be connected to some long-term pattern unfolding across the universe? Or was it a rare and isolated anomaly that would fade quickly? Scientists remain divided on the outcome. Some believe the disturbance will stabilize over time, while others fear it could continue to spread, causing unpredictable consequences throughout the universe. As Atlas continues to monitor this unfolding event, new questions emerge daily. While current data offers a chilling glimpse into a universe far more volatile than we had realized, it also points to something even more extraordinary. A cosmic puzzle that may lead to the discovery of new forces, laws of physics and dimensions of space-time that were once only theoretical. Stay tuned as we explore what comes next in this ongoing cosmic mystery. The story is only beginning, and the universe may have far more secrets to reveal than we could have ever imagined. As scientists delve deeper into the anomalies triggered by the ATLAS discovery, they realize that the disturbances were not merely a result of visible energy or radiation. What became evident was that invisible forces, previously undetected, seemed to be playing a role. The most significant of these was dark matter, an enigmatic substance that makes up roughly 27% of the universe, but has eluded direct detection for decades. Initially, dark matter was thought to be passive, influencing cosmic events in ways difficult to observe. However, the brightening event detected by ATLAS suggested that dark matter might be actively involved, contributing to the disturbance in ways previously unanticipated. Scientists hypothesized that dark matter wasn't just a passive presence, but an active agent. Perhaps the energy released by the event interacted with dark matter, triggering the violent reactions seen across space. If this were the case, it would imply that dark matter plays a much more dynamic role in cosmic events than previously realized. The question now was how this invisible substance could be linked to space-time instability. One theory was that the disturbance caused a fluctuation in dark matter distribution, which led to the collapse of gravitational fields and space-time irregularities observed by ATLAS. Researchers also investigated the possibility that dark energy, a force responsible for the universe's accelerated expansion, might be involved. Could it be that the energy released by the Atlas event was powerful enough to interact with dark energy fields, distorting them in a way that accelerated the disturbance's spread? Could this disturbance result from dark matter interacting with dark energy, creating a force capable of disrupting the fundamental laws of physics? If true, it would mean that we've only scratched the surface of understanding the true nature of the universe. For centuries, dark matter and dark energy have been thought of as separate, elusive components. Yet, the ATLAS event could suggest they are more deeply connected, and their combined influence might be far greater than we imagined. To test this theory, researchers are using advanced simulations and computational models. By recreating the event conditions, scientists are looking for any sign that dark matter and dark energy acted in concert, amplifying the disturbance. Early results are promising but far from conclusive. More tantalizing is the possibility that the disturbance revealed a previously unknown form of dark matter or energy. Scientists have long speculated that there may be multiple types of dark matter, some of which may be more interactive. The Atlas discovery may have uncovered one of these exotic forms, and its interaction with space-time could be something entirely new to physics. As new data from ATLAS floods in, researchers are eager to test this theory further. To truly understand the role of these invisible forces, They will need to develop more sophisticated tools to detect and measure dark matter and dark energy in real time. This could lead to a breakthrough in how we observe the universe, forever changing our understanding of cosmic forces. If dark matter and dark energy are responsible for the chaos unleashed by the Atlas event, we are on the precipice of a monumental discovery. It would not only rewrite textbooks on astrophysics, but could open the door to new realms of scientific exploration. Could this be the key to understanding the fundamental nature of the universe, or will it deepen the mystery? One thing is certain: the invisible forces that govern the cosmos are far more complex and intertwined than we ever imagined. And with each new piece of data from ATLAS, we are closer to unveiling the secrets of these elusive phenomena. What we discover next could change everything we thought we knew about space, time, and the very forces that shape our universe. Stay with us as we continue this journey into the unknown. As the data from ATLAS continued to pour in, the role of black holes in the cosmic disturbance became increasingly significant. These enigmatic objects, which have fascinated scientists for decades, began to exhibit strange behaviours in the wake of the brightening event. The connection between the disturbance and the observed activity in black holes was impossible to ignore, and researchers turned their attention to understanding how these massive gravitational entities might be involved in the spreading chaos. Black holes, by definition, are regions of space where gravity is so intense that nothing, not even light, can escape. They form when massive stars collapse under their own gravity, creating a singularity, a point of infinite density. Surrounding the singularity is the event horizon, the boundary beyond which nothing can return. Scientists have long studied these objects, but they remain one of the most mysterious phenomena in the universe. What made the latest development perplexing was that black holes were not merely reacting to the disturbance, they were amplifying it. Scientists found that the event horizons of black holes in affected regions were expanding and contracting in irregular patterns. This fluctuation had never been seen before. Black holes, once considered stable, were now behaving erratically, as if responding to an external force that had shaken the core of their existence. The black hole's behaviour extended beyond the immediate region around the disturbance. Astronomers noticed that their gravitational influence was spreading, affecting nearby stars and even causing ripples in the gravitational fields of galaxies far from the disturbance's epicenter. This suggested that the disturbance might have triggered a catastrophic destabilization in the gravitational equilibrium of space-time caused by the energy released during the brightening event. One of the most startling hypotheses put forward by astronomers was that these black holes might be interacting with the disturbance in unprecedented ways. The rapid fluctuations in their event horizons suggested that the fabric of space-time around them was being disturbed on a massive scale. Could the energy released by the brightening event have been strong enough to destabilize black holes across the galaxy? If this hypothesis is correct, it would mean the disturbance initiated a feedback loop in which black holes amplified the chaos instead of just responding to it. This would indicate that the event wasn't a passive occurrence but an active force altering the structure of space-time itself. To understand the disturbance's magnitude, scientists began running simulations of black hole dynamics. These models predicted how black holes and surrounding space-time would behave under the influence of such a powerful disturbance. Early results were staggering. They suggested that if the disturbance continued, it could destabilize the orbits of entire star systems. In the worst-case scenario, gravitational disturbances could shift entire galaxies, throwing once stable systems into chaos. The implications were mind-boggling. If black holes were playing such an active role in the cosmic disturbance, it could lead to the collapse of galactic structures. The immense gravitational pull of these black holes could draw stars inward toward their singularities, triggering star deaths and supernovae. Entire solar systems could be ejected from galaxies, hurled into intergalactic space. Though these scenarios may seem extreme, they align with some of the most cutting-edge models of black hole dynamics. As scientists continue to monitor their behaviour, it's becoming clear that black holes are not passive participants in the cosmic drama unfolding. They are active agents, and their influence could be key to understanding the true nature of this cosmic crisis. As the Atlas team and other researchers refine their models and gather more data, the central question remains: what will happen if the black holes continue to destabilize? Will their influence spread, creating a ripple effect that destabilizes the entire galactic structure? Or will the event eventually subside, leaving behind only the echoes of its disturbance? For now, the answers remain unclear. But it's certain that this new chapter in the study of black holes is revealing more about these mysterious objects and shedding light on the fundamental forces governing the universe. The disturbance has opened up a new realm of possibilities, one that may forever change our understanding of space, time, and the objects at the heart of every galaxy. Stay with us as we delve deeper into the cascading effects of this cosmic event and explore the potential consequences for the universe as we know it. This mystery is far from over, and the answers we uncover may be more profound than we ever imagined. As the disturbance continued to unfold, a concerning realization began to take shape. The event was having a profound impact on the structure of entire galaxies. Galaxies, vast systems of stars, gas, dust, and dark matter bound together by gravity, were suddenly showing signs of instability. The delicate balance that keeps galaxies intact, with stars orbiting a central supermassive black hole, seemed to be under threat. What began as a localized anomaly was rapidly evolving into a massive disturbance that altered the very architecture of galaxies themselves, causing systems to shift in ways never before observed. At first, scientists weren't sure whether these changes were a direct consequence of the disturbance or a long-term result. However, as more data came in, it became clear that the disturbance in spacetime was beginning to alter the orbits of stars, gas clouds, and even black holes, pushing them out of their traditional paths. The magnitude of these shifts suggested that the disturbance was far more than a burst of energy. It was a force capable of altering the gravitational dynamics of entire galactic systems. To understand the full scope, scientists first focused on the centers of affected galaxies, where supermassive black holes are located. These black holes were once thought to be stable, with their gravitational influence extending only to their immediate surroundings. However, the disturbance triggered by the ATLAS event began causing fluctuations in the gravitational fields around these central black holes. In some cases, these fluctuations were strong enough to shift the orbits of entire clusters of stars, causing them to veer off their usual paths. The disturbance's effects weren't confined to stars alone. The gas and dust that make up the spiral arms of galaxies began to exhibit erratic behavior as well. These gas clouds, which typically follow well-defined orbits around the galactic center, began to accelerate, some even escaping their galaxy's gravitational pull. Entire regions of galaxies appeared to be moving as though pushed by an unseen force, hinting at something far more powerful at play than just a localized cosmic event. This raised a new and alarming possibility. Could the disturbance be causing galaxies to collide or merge at an accelerated rate? Galactic collisions, which usually occur over millions or billions of years, might now be happening much faster. If such mergers occurred, they could destabilize these systems, triggering star system disruptions, bursts of new star formation, and possibly causing entire galaxies to lose their structural integrity. Astronomers quickly noted that while galactic mergers are a part of the universe's natural life cycle, they typically occur on long time scales. The current disturbance, however, had the potential to speed up this process, pushing galaxies into dangerous interactions. The energy released by the event could act as a catalyst, causing galaxies to move into uncharted territory. The possibility of multiple galaxies colliding or even one galaxy slingshotting out of its position was now very real. Scientists also considered the formation of entirely new cosmic objects. Could these altered gravitational dynamics lead to the creation of new black holes or neutron stars in the wake of galactic disruptions? Might the accelerated gas clouds form stars at an accelerated rate, creating intense stellar activity? Or could the disturbance destroy existing stars, throwing their orbits off course to the point of no return? Beyond individual galaxies, astronomers began contemplating the broader consequences of these galactic shifts. What would happen if the disturbance began to affect galaxy clusters, groups of galaxies bound by gravity? These clusters are the largest gravitationally bound structures in the universe, and if they were destabilized, the consequences could be catastrophic. Entire groups of galaxies could be flung into intergalactic space, leaving behind voids that disrupt the very fabric of the universe. To understand these effects, researchers turned to simulations. Using the latest computational models, they began to simulate how galaxies and their components would respond to the disturbance. Early results suggested that the universe might be on the verge of a massive reorganization, one that could reshape the cosmic landscape in ways previously unimaginable. The ultimate question now is whether these galactic shifts are only the beginning. Could this disturbance be part of a larger cosmic cycle, triggered by the forces of dark matter, dark energy, and black holes? And if so, what does this mean for the future of our own galaxy, the Milky Way? Could our galaxy be next in line for a cosmic upheaval? As the investigation continues, scientists are realizing they may be witnessing the early stages of a cosmic transformation, a reordering of the universe that could alter everything we know about space, time, and the laws of physics. While the answers remain elusive, one thing is certain: the universe is far more dynamic and unpredictable than we ever imagined. Stay with us as we continue to explore the unfolding mysteries of this cosmic event. The next developments could forever change how we understand our place in the cosmos. As the disturbance continued to unfold, a new and alarming theory began to gain traction. The brightening event might not just be a localized cosmic flare, but a rift in the very fabric of space-time. Space-time, as theorized by Albert Einstein, is the four-dimensional continuum that binds the three dimensions of space with the dimension of time. It forms the foundation of the universe, and its stability is essential to everything that exists. If the disturbance were indeed linked to a rupture in space-time, the implications could be extraordinary. To understand the gravity of this possibility, it's important to first grasp the concept of space-time. Space and time are interwoven in such a way that the presence of mass or energy can warp this fabric, creating what we experience as gravity. In a stable universe, this fabric remains intact, with gravitational forces from planets, stars, and black holes adhering to predictable patterns. However, the data from ATLAS suggested that the delicate fabric of space-time was being disrupted on an unprecedented scale. While the idea of a space-time rift isn't entirely new, physicists have speculated about such events, especially in the context of black holes and wormholes. Witnessing a space-time disruption of this magnitude was unheard of. The signals from Atlas indicated something more than a localized event. It appeared to be a massive rupture, a tear in the very structure of the universe itself. This could potentially represent the breakdown of one of the most fundamental pillars of our reality. As scientists analyzed the data, they found evidence of space-time warping in a way never observed before. Instead of the smooth curvature expected from gravitational influence, there were sharp, jagged distortions, almost as though the fabric of space-time was being torn apart. These signals could not be explained by any known forces or objects, even black holes, which have a profound impact on space-time. The magnitude of the disruption was far beyond anything previously observed. Researchers began to hypothesize that the disturbance might be linked to the interaction between dark matter and dark energy, two mysterious forces that have puzzled scientists for decades. If these forces were triggered by the brightening event, could they have become powerful enough to tear at space-time itself? If true, this would mean the universe might not be as stable as we once thought. The forces that govern gravity, light, and even time could be more fragile than we ever imagined. The potential consequences of such a rift could be catastrophic. If space-time itself were destabilized, it might lead to a disruption in the speed of light. This would cause distortions in how light travels through space, affecting our observations of distant galaxies, stars, and cosmic phenomena. Essentially, the universe might no longer adhere to the familiar rules of distance and time, distorting our understanding of space. Additionally, a rift in space-time could destabilize gravitational fields, causing galaxies, star systems, and black holes to shift unpredictably. The gravitational pull that keeps the universe intact could begin to fluctuate, causing planets and stars to drift from their usual orbits. In the worst-case scenario, such a disruption could lead to the collapse of entire galactic structures, creating a chaotic and unstable universe. While the rift appeared to be distant, scientists were growing increasingly concerned about the long-term effects. Could this disturbance eventually spread to our own galaxy? What if the instability began to affect our solar system, altering the orbits of planets and potentially bringing them into collision? While the chances of such an event happening immediately are low, the fact that space-time itself is being altered on such a large scale raised questions about the long-term stability of the universe. To better understand the rift's potential impact, physicists turned to simulations. By comparing data from gravitational wave detectors and space telescopes, they aimed to pinpoint the disturbance's location and scope. However, the data remained inconclusive, with scientists unable to fully grasp what was causing the rift or how far it would extend. What was becoming clear, however, was that this disturbance marked a pivotal moment in the history of cosmic research. If space-time could truly be altered on such a scale, it would challenge everything we thought we knew about the universe. The laws of physics, once considered immutable, might not be as unchanging as we once believed. The ultimate question remains whether this rift is an isolated event or the beginning of a larger cosmic shift. Could the universe be entering a new phase, where the very structure of space-time is subject to instability? And if so, how should humanity prepare for the unknown consequences of this cosmic upheaval? As scientists continue to gather data and refine their models, the answers remain elusive. But one thing is clear: the universe is revealing unexpected truths about itself. The disturbance may be just the beginning, and the coming months may bring revelations that forever alter how we view the cosmos. Stay with us as we track the progress of this cosmic event, exploring the mysteries of space-time, dark matter, and the forces that shape our universe. The story is unfolding, and we are only beginning to understand the true nature of the forces at play. As the months passed and data from ATLAS continued to accumulate, one undeniable truth emerged. The disturbance was not a transient event. It was expanding, not only in its influence but in its effects, spreading across the cosmos with a force that defied the natural limits of cosmic disturbances. What started as a localized anomaly now seemed to be expanding outward, influencing more distant regions of space. It was as if the universe itself had begun to vibrate in response to the disturbance, triggering a cosmic ripple effect. Astronomers and physicists struggled to comprehend the scale of this event. No known phenomenon had ever shown such a tendency to expand across vast distances so quickly. If this was truly the result of the initial brightening event detected by ATLAS, the implications were staggering. Could an event that started as a single burst be capable of spreading chaos throughout the universe, altering the state of galaxies, stars, and space-time? The idea of cosmic chaos, in which events once thought to be rare occurrences became widespread, raised serious concerns about the long-term stability of the universe. A disturbance expanding at this rate might mean the laws governing the universe, such as gravity and time, could no longer be trusted. If chaos could propagate, the universe might no longer remain predictable or stable. Entire regions of space that were once calm could suddenly become volatile, affected by the same forces triggered by the ATLAS event. One perplexing aspect of the disturbance's spread was the role of dark matter and dark energy. Initially considered passive components of the cosmos, these forces were now playing a more active role. Dark matter, once thought to only influence galaxies' movements, seemed to amplify the effects of the disturbance. Could dark matter be driving the disturbance across the universe? Or was it possible that the disturbance was moving through regions of space where dark matter was concentrated, using it as a conduit to expand further? At the same time, dark energy, the mysterious force responsible for the universe's accelerated expansion, was also under scrutiny. Could the disturbance be interacting with dark energy, triggering it in a way that pushed against space-time? If true, this could mean the disturbance was not just a consequence of the event, but was being driven by dark energy, further accelerating its spread. The implications were mind-boggling. The force responsible for the universe's expansion could now be aiding the spread of cosmic chaos. As scientists tracked the growing scope of the disturbance, gravitational wave observatories like LIGO and Virgo were monitoring the fluctuations in space-time. The data confirmed that the disturbance was not a single event but part of a larger cosmic transformation. Gravitational waves from the disturbance were intensifying, and the ripples in space-time were spreading farther. Some scientists speculated that the disturbance could trigger a cosmic rebirth. The rapid expansion could act as a catalyst for creating new cosmic structures, stars, galaxies, even black holes. It seemed the universe was undergoing accelerated evolution, giving birth to new forms of cosmic order. In this sense, the disturbance might not only be destructive, but could signal a new phase in the universe's life cycle. However, not all scientists shared this optimism. Many feared the disturbance might unravel the universe's structures. If it continued to destabilize galaxies, black holes, and space-time, it could collapse entire galactic clusters. This could leave behind a universe unrecognizable, a chaotic, fractured space where even the laws of physics no longer applied. A growing concern was whether the disturbance could reach our own galaxy, the Milky Way. Though the event began far away, the rapid expansion meant it could now affect our galaxy. If it did, it could destabilize the entire galaxy, altering the orbits of stars and even disrupting planets in our solar system. Could the Milky Way survive the chaos spreading across the universe? This concern prompted a global collaboration between space agencies and research institutions. NASA, ESA, and others began working together to create contingency plans for possible cosmic upheaval. They developed advanced telescopes and instruments to monitor the disturbance in real time, while also considering ways to mitigate its impact on our solar system. The concept of cosmic resilience, preparing for space-time disruptions, became a critical area of research. As the cosmic upheaval unfolded, the universe seemed to be testing the limits of our understanding. The disturbance forced humanity to confront new questions. What happens when the universe begins to break down? How can we adapt to a cosmos where space, time, and gravity are no longer stable? Scientists continue to monitor the situation closely, racing to understand the full implications of the event. The answers remain elusive, but one thing is clear. We are witnessing a cosmic event of unprecedented scale, one that could change the course of the universe itself. As we stand at the precipice of this unknown future, humanity's understanding of the cosmos will be forever altered. Stay with us as we continue to explore the growing mysteries of this cosmic disturbance. The story is far from over, and the answers we seek may forever reshape our understanding of the universe. As the months passed and data from ATLAS continued to accumulate, one undeniable truth began to emerge. The disturbance was not a transient event. It was expanding, not only in its influence but in its effects, spreading across the cosmos with a force that defied the natural limits of cosmic disturbances. What began as a localized anomaly seemed to be spreading outward, influencing more distant regions of space. It was as though the universe itself had started to vibrate in response to the disturbance, triggering a cosmic ripple effect. Astronomers and physicists struggled to comprehend the scale of this event. No known phenomenon had ever shown such a tendency to expand so rapidly across vast distances. If this was the result of the initial brightening event detected by ATLAS, the implications were staggering. Could an event that started as a single burst propagate chaos throughout the universe, altering galaxies, stars, and space-time itself? The idea of cosmic chaos, in which once rare events became widespread, raised serious concerns about the long-term stability of the universe. A disturbance capable of expanding at this rate might mean that the laws of gravity and time could no longer be trusted. If chaos could propagate, the universe we knew might no longer remain predictable. Entire regions of space that were once calm could suddenly become volatile, affected by the same forces that triggered the ATLAS event. One perplexing aspect of the disturbance's spread was the role of dark matter and dark energy. Initially, dark matter was considered a passive component of the cosmos, a mysterious substance that influenced galaxies' movements but remained largely invisible to our instruments. However, the disturbance revealed that dark matter might be playing a more active role in the fabric of the universe than previously understood. Researchers theorized that dark matter wasn't just a passive player, but an active participant in the spread of cosmic chaos. Could dark matter be amplifying the effects of the disturbance, causing it to propagate across the universe? Or was it moving through regions of space where dark matter was most concentrated, using it as a conduit to expand further? At the same time, dark energy, the force responsible for the accelerated expansion of the universe, was also scrutinized. Could the disturbance interact with dark energy, triggering it in a way that pushed against space-time? If true, the disturbance could be driven by dark energy, accelerating its expansion. This would mean the force responsible for the universe's expansion could now aid the spread of cosmic chaos. As scientists tracked the growing scope of the disturbance, gravitational wave observatories like LIGO and Virgo monitored fluctuations in space-time. The data confirmed that the disturbance was part of a much larger cosmic transformation. The gravitational waves emanating from it were intensifying, and the ripples in space-time were spreading farther. Some scientists speculated that the disturbance could trigger a cosmic rebirth. The rapid expansion might act as a catalyst for creating new cosmic structures, stars, galaxies, even black holes. It seemed as though the universe was undergoing accelerated evolution, giving birth to new forms of cosmic order. In this sense, the disturbance might not only be destructive but could signal a new phase in the universe's life cycle. However, not all scientists shared this optimism. Many feared the disturbance could unravel the universe's structures. If it destabilized galaxies, black holes, and space-time, it could lead to the collapse of entire galactic clusters. These events might leave behind a chaotic universe where the laws of physics no longer applied. A growing concern was whether the disturbance could reach our own galaxy, the Milky Way. Although it began far away, the rapid expansion meant it could now affect us. If it did, it could destabilize the entire galaxy, altering the orbits of stars and disrupting our solar system. Could the Milky Way survive the chaos spreading across the universe? This concern prompted a global collaboration between space agencies and research institutions. NASA, ESA, and others began working together to create contingency plans for cosmic upheaval. Advanced telescopes and instruments were developed to monitor the disturbance in real time, while ways to mitigate its impact on our solar system were considered. The concept of cosmic resilience, preparing for space-time disruptions, became critical. As the cosmic upheaval unfolded, the universe seemed to be testing the limits of our understanding. The disturbance forced humanity to confront new questions. What happens when the universe begins to break down? How can we adapt to a cosmos where space, time, and gravity are no longer stable? Scientists continue to monitor the situation closely, racing to understand the full implications. While answers remain elusive, it's clear we are witnessing a cosmic event of unprecedented scale, one that could change the course of the universe. As we stand at the precipice of this unknown future, humanity's understanding of the cosmos will be forever altered. Stay with us as we continue to explore the growing mysteries of this cosmic disturbance. The story is far from over, and the answers we seek may forever reshape our understanding of the universe. As the cosmic disturbance grew more complex, a new set of questions began to emerge. What does this upheaval mean for humanity? The universe, once thought to be a stable backdrop to human existence, was now showing signs of volatility that could fundamentally alter our understanding of our place within it. The disturbance raised profound questions about the stability of the universe and our role in it. Could the chaos unfolding across space affect Earth? Or is humanity somehow tied to these larger events? For centuries, humans have observed the stars seeking answers through scientific discovery and philosophical pondering. We've seen ourselves as observers, standing apart from the cosmic processes that govern everything from the birth of stars to the death of galaxies. Yet now, with the universe in flux, we may no longer be passive observers. The disturbance is forcing us to confront our place in the vast cosmos. If the laws of physics are changing, what does this mean for Earth and our future? Scientists began to ask whether humanity was at risk from the cosmic chaos. Could the disturbance, now spreading across galaxies, eventually reach the Milky Way? Although the event seemed distant, its effects on neighbouring galaxies were undeniable. Could our galaxy be destabilized in the same way, leading to unpredictable changes in our solar system? If entire star systems were being displaced, what would happen to Earth? Would it be thrown out of orbit, hurled into deep space, or subjected to unknown forces? While such scenarios may sound like science fiction, scientists could not dismiss the possibility that these disturbances might affect the stability of our solar system. The vastness of space means that even though Earth is isolated, the influence of cosmic events can reach far. The idea that a destabilized galaxy could affect its surrounding space-time, and by extension our solar system, raised concerns about the long-term stability of Earth. Despite these fears, some researchers see the disturbance as an opportunity for growth and discovery. They believe studying the event's effects on distant galaxies and stars could uncover hidden aspects of the universe. This upheaval might open the door to a new era of exploration, where humanity is forced to look beyond Earth and venture into the unknown. Understanding space-time, dark matter, and dark energy could lead to breakthroughs that change how we interact with the universe. In a sense, the disturbance is forcing humanity to confront its place in the cosmos, not just as observers but as active participants in a vast dynamic universe. It's a humbling realization that we are part of the same cosmic web as stars and galaxies. The fact that we are witnessing the disruption of nature's laws challenges our previous ideas of stability. It forces us to ask how humanity, fits into cosmic evolution, and what role we might play in the future of the universe. The disturbance, with all its unsettling consequences, also represents a challenge for humanity to adapt. Just as stars and galaxies undergo cycles of creation and destruction, humanity must prepare for its place in this cosmic dance. It raises the question, how can we prepare for an uncertain future in a universe where space-time is in flux? In response, many scientists are working to predict and mitigate the effects of the disturbance. They are developing technologies to monitor cosmic events in real time and creating models to understand the disturbance's underlying causes. The goal is not just survival, but to thrive in this evolving universe. Could this chaos, in some strange way, lead to a new understanding, one that allows humanity to adapt to the forces shaping our destiny? Space exploration's role has never been more critical. As the disturbance continues to expand, humanity must look to the stars for answers. Research on space-time, black holes, dark matter, and dark energy will not only reveal the nature of the disturbance, but also help us navigate a universe in flux. The future of space exploration is uncertain, but this crisis could be the catalyst for a new era of discovery and adaptation. In the face of uncertainty, humanity's quest for knowledge will continue. While the answers remain elusive, the search for understanding and the drive to survive will guide us. The disturbance shaking the universe may one day be seen as a turning point in human history. It is forcing us to rethink our relationship with the cosmos, pushing us to reconsider our place in the grand scheme of things. As we continue to monitor the situation, the question remains, how will humanity respond to the challenges of a universe in flux? Will we rise to the occasion and adapt to a new understanding of space and time? Or will we be caught unprepared as the universe unfolds its mysteries? Stay with us as we explore the consequences of this cosmic upheaval and uncover what the future holds for humanity and the universe. What we discover next could change everything we know about our existence and the very nature of the cosmos itself. As the cosmic disturbance grew more complex, a new theory began to gain traction: the possibility that the universe was heading toward its own endgame. This theory, once speculative, now seemed increasingly plausible due to the unprecedented disruption of space-time, the destabilization of galaxies, and the breakdown of cosmic order. Could the disturbance be a precursor to a larger, catastrophic event that might lead to the collapse of the universe? The endgame theory suggests that the disturbance could be a symptom of a deeper issue, one that might result in the collapse of the universe's fundamental structure. If true, this could mean that the cosmos, once vast and stable, might be on the verge of a final breakdown. The very fabric of space-time, which had once held everything together, could be disintegrating. The disturbance might be the first of many catastrophic events signaling the end of the universe's current phase. This scenario is often linked to the heat death theory, where entropy, or disorder, reaches its maximum state. In this view, the universe becomes cold, dark, and lifeless, with energy evenly spread out and no ability for new structures or life to emerge. If the disturbance is accelerating entropy, it could be pushing the universe toward this inevitable end. However, a more dramatic possibility also exists: the collapse of space-time itself. If the disturbance continues, it could trigger a big crunch, where all matter and galaxies collapse into a single point. This catastrophic event could be triggered by a destabilization in space-time, a cosmic implosion that starts at the disturbance's core and accelerates outward. While these scenarios seem extreme, they are based on scientific principles. The idea of space-time collapsing or entropy reaching its maximum state is not new, but the rapid acceleration of instability, sparked by the ATLAS disturbance, forces scientists to consider that these once theoretical endgame scenarios might be closer than anyone realized. The key question is whether the universe can recover. Could the disturbance be contained or reversed, or has cosmic decay already begun? The evidence suggests the disturbance is too widespread and powerful to fade away. The chaos, the unraveling of galaxies, and the destabilization of space-time all point to a universe in flux, one that might be heading toward its end within our cosmic lifetime. Some researchers hold out hope that the disturbance is part of a new phase in universal evolution. The universe has gone through periods of instability before, from the Big Bang to the formation of galaxies and stars. Perhaps the disturbance marks the beginning of a new cosmic era, one where space-time and cosmic structures are continuously redefined. This view suggests that what seems like an ending might be the catalyst for a new beginning, where the universe continues to evolve. But this optimistic view is tempered by growing fears. The rate at which galaxies are destabilizing and the erratic behavior of space-time indicate we may be witnessing a collapse on a scale impossible to reverse. The disturbance seems to be pushing the universe toward an irreversible tipping point, where it will no longer be able to sustain itself. Even in the face of this potential catastrophe, there remains a strong drive within the scientific community to understand and explore. Researchers are using advanced instruments to monitor the spread of the disturbance. The data they collect will likely shape future theories on the fate of the universe. It's also possible that these observations will lead to breakthroughs in understanding and manipulating space-time. The disturbance could push humanity to confront not just the universe's end, but also its potential rebirth. However, the unsettling truth is that no one can know for certain what lies ahead. The future of the universe is now uncertain, and what once seemed like scientific certainties may no longer hold true. The disturbance has pulled back the curtain on a new era, one where the laws of physics are in flux and the fate of the universe is no longer guaranteed. As we move forward, the question remains: is this disturbance the beginning of the end or the start of something new? What is clear is that the universe is undergoing a fundamental transformation, one that will change our understanding of reality itself. For humanity, standing at the edge of this cosmic upheaval, the future is uncertain. Stay with us as we continue to explore the mysteries of this cosmic disturbance and uncover what the future may hold for the universe. What we learn in the coming months could forever change our perspective on the universe and our place within it. As the universe reacts to the disturbance, an emerging theory offers a more optimistic possibility, that this upheaval might not mark the end of the universe but the beginning of a new cosmic phase. This theory suggests that, while seemingly catastrophic, the disturbance could serve as a catalyst for the universe's transformation, a cosmic rebirth that might bring new structures, forms of matter, and even new laws of physics. The idea of cosmic rebirth is rooted in certain interpretations of quantum mechanics and cosmology, which propose that the universe undergoes cycles of creation, destruction, and renewal. Just as stars are born and die, the universe itself might experience periodic rebirths, marked by shifts in its fundamental properties. In this view, the disturbance could trigger a new cycle, one that ushers in a radically different cosmic order. If the disturbance is indeed a precursor to such a rebirth, the question becomes, what would this new universe look like? How would the forces that govern space, time, and matter change? One possibility is that the fabric of space-time itself could transform. If the disturbance ruptures space-time, it could pave the way for new forms of space, new dimensions, or even entirely new laws of physics. Imagine a universe where gravity, light, and energy behave in ways we can't yet comprehend, where the very building blocks of reality are fundamentally different. In this new cosmic cycle, stars might be born from the remnants of the collapse, emerging in new and unexpected ways. Galaxies colliding could merge to form new cosmic structures, creating more stable systems of stars and planets. The chaotic events we are witnessing could eventually lead to the creation of more resilient forms of order, a universe that adapts and evolves in response to instability. This theory also suggests that the universe may no longer be bound by entropy, the force of cosmic decay. As the universe regenerates, it could give rise to conditions where entropy no longer drives it toward maximum disorder. Instead, the disturbance might reset the laws of thermodynamics, creating an environment where energy flows in new patterns, allowing for new kinds of interactions between matter, energy, and space-time. This could create new forms of life, structures, and consciousness. While this concept of a cosmic rebirth sounds optimistic, it remains speculative. There is no direct evidence yet that this transformation is happening. However, the ongoing cosmic chaos caused by the disturbance is forcing scientists to reconsider cosmic evolution. If we are in the midst of a major transformation, humanity might be witnessing the early stages of a dramatic shift in how the universe operates. One challenge to understanding this possibility is the unknowns surrounding the disturbance itself. If the event continues to spread and destabilize the cosmos, it may reach a point where we can no longer observe the universe as we know it. Our instruments might be ill-equipped to detect the subtle changes in space-time, as the universe operates under entirely new rules. What we are witnessing may be the precursor to a new era of cosmic physics, one that can only be understood with new scientific frameworks and technologies. For now, researchers continue to monitor the situation. Using advancements in astrophysics and cosmology, they are mapping the disturbance's trajectory and attempting to predict how it will evolve. Some scientists are already modelling what a post-disturbance universe might look like, exploring how space-time parameters might behave under these new conditions. Though these models are still in the early stages, they represent the cutting edge of theoretical science, driven by unprecedented data from ATLAS and other observatories. Many in the scientific community hope that, should this cosmic rebirth occur, it will provide humanity with opportunities for greater understanding and exploration. A universe with new laws of physics and forms of matter could unlock previously unimaginable possibilities. Space travel, colonization, and even the fundamental understanding of reality could be transformed. Humanity might be on the cusp of a new cosmic frontier where the boundaries of possibility are limitless. Despite the uncertainty, there is a sense of awe that comes with witnessing this cosmic upheaval. The universe, for all its vastness and complexity, is still full of mysteries waiting to be uncovered. If this disturbance marks the beginning of a new cosmic era, it could serve as a reminder that the universe is more dynamic and alive than we ever imagined. It is constantly evolving, with cycles of creation and destruction that shape its destiny. As the disturbance continues to spread, humanity must remain vigilant and open to the possibility of discovery. Whether this cosmic chaos signals the end or a new beginning, we are witnessing an event that will forever change our understanding of the cosmos. The future remains uncertain, but one thing is clear: the universe is not static. It is changing, evolving, and in that change lies both the unknown and the promise of discovery. Stay with us as we continue to track the ongoing developments in this cosmic upheaval. What we learn in the coming months and years may forever reshape our perspective on the universe and our place within it. As the disturbance unfolded and its cosmic implications deepened, scientists began investigating a phenomenon long relegated to theoretical discussions: the potential for a quantum shift in the fabric of the universe. Quantum mechanics, governing the smallest particles of matter, has always operated on the scale of atoms and subatomic particles. However, the cosmic disturbance raised the possibility that quantum mechanics could be altered on a cosmic scale. In classical physics, the universe operates in predictable patterns. But quantum mechanics, at the smallest scales, is governed by probabilities and uncertainties. Subatomic particles like electrons and photons don't have fixed positions or velocities. Instead, their behavior is described by probability distributions. This randomness has puzzled scientists for decades, but remains one of the most successful aspects of modern physics. Yet, the disturbance detected by ATLAS, which has destabilized space-time and altered the laws of gravity, energy, and matter, suggested something entirely new: a potential quantum shift in reality itself. What if the disturbance wasn't just a disruption in space-time, but a change in the quantum field that governs the particles making up the universe? One central question is whether space-time itself is composed of quantum particles. In current models, space-time is continuous, bending and stretching under gravity. But what if space-time is composed of discrete, indivisible units, quantum grains of space-time? If so, the disturbance could be causing a fundamental shift in how space-time operates, much like how quantum phenomena can change particle behavior. A quantum shift in space-time could have profound consequences. If space-time is made up of discrete units, our understanding of the universe would be drastically altered. The laws of physics, including gravity, the speed of light, and time itself, might no longer be fixed. If quantum forces can reshape space-time, it could open the door to new possibilities, including new dimensions, time travel, or the ability to manipulate the fabric of the universe itself. The quantum shift theory also raises deep questions about the nature of reality. If the disturbance is causing a quantum change in space-time, the universe might be becoming something entirely different. In this new reality, the boundaries between space and time could blur, creating a dynamic environment where the laws of physics as we know them no longer apply. This could mean the end of our familiar universe, replaced by a new set of rules and interactions. To explore this, scientists have turned to quantum gravity, a theoretical framework that merges quantum mechanics with relativity. Quantum gravity aims to describe space-time at the smallest scales, where quantum effects dominate. If the disturbance is tied to quantum gravity, it could offer insights into how space-time and quantum fields interact on a cosmic scale. Physicists are also exploring how quantum mechanics could influence large-scale cosmic structures. The idea of quantum foam, which suggests space-time is made of tiny, fluctuating quantum particles, has gained attention. If quantum foam exists on a cosmic scale, it might explain the irregularities observed in the disturbance. This cosmic chaos could be a result of shifts in quantum foam, causing fluctuations in space-time that disrupt galaxies, stars, and black holes. The research into quantum gravity combined with the disturbance is opening a new frontier in our understanding of the universe. As more data comes in from ATLAS and other observatories, scientists are beginning to build models that incorporate quantum principles into cosmic phenomena. These models, still in their early stages, represent a groundbreaking shift in how we think about the universe. What was once the domain of subatomic particles is now being applied to the vast, infinite cosmos. The potential for a quantum shift is both exhilarating and unsettling. If the laws of physics are changing at a fundamental level, the universe could be undergoing a radical transformation that reshapes our understanding of space, time, and reality. This shift could open new avenues for exploration: time travel, interdimensional travel, and the manipulation of space-time. But it also raises the possibility that the universe, as we know it, could be fundamentally altered in ways we can't yet predict. As scientists continue to investigate the disturbance's effects on quantum mechanics, we are witnessing a revolution in our understanding of the cosmos. The disturbance may signal a deeper transformation, one that challenges everything we thought we knew about the universe. The quantum shift theory is just one of many possibilities, but it marks a profound step forward in our quest to understand the true nature of reality. Stay with us as we continue to unravel the mysteries of this cosmic disturbance and explore the potential for a quantum revolution in the universe. The answers may be closer than we think, and the revelations ahead could reshape our very understanding of existence. As the disturbance continues to unfold, scientists are exploring more speculative theories to explain the unprecedented events shaking the universe. One such theory, once relegated to the realm of science fiction, is now gaining traction: the multiverse hypothesis. This theory suggests that our universe, as vast and complex as it seems, is just one of many universes that exist in parallel. Could the disturbance, with its far-reaching effects on space-time, indicate that our universe is interacting with others in the multiverse? The multiverse theory posits that the universe we observe may not be the only one in existence. Instead, there could be countless universes, each with its own set of physical laws and structures. Some universes might resemble our own, while others could be radically different. These universes could exist in separate dimensions or be hidden in different pocket realities that are inaccessible to ours. If the disturbance is linked to interactions with these parallel realities, it would represent a new kind of cosmic phenomenon, one that blurs the lines between universes and challenges our understanding of what is possible. The effects of the disturbance observed in space-time warping and the destabilization of galaxies might not be confined to our universe. They could be the result of a collision between our universe and another, allowing energy, matter, and space-time to bleed through from one universe to another. One aspect of the multiverse theory that could explain this disturbance is brane theory from string theory. According to this model, our universe might be a brane, a multi-dimensional object embedded within a higher dimensional space. The disturbance could be caused by a collision between our brane and another, disrupting space-time and causing the strange effects detected by Atlas. Another intriguing possibility is that different universes could have different physical constants, such as the strength of gravity or the behavior of particles. If our universe were to interact with one where these constants were significantly different, it could cause catastrophic effects on space-time, leading to the instability we are witnessing. The disturbance could thus be the first sign of a larger cosmic interaction, one that reshapes the multiverse. This potential for a collision raises important questions. What happens to matter and energy when universes collide? Could such interactions result in the creation of new universes or the destruction of existing ones? The multiverse theory suggests that in a larger cosmic framework, the death of one universe could give birth to another, a continuous cycle of creation and destruction across infinite dimensions. If the current disturbance is part of this cycle, it might represent the transition from one phase of universal evolution to another. The implications of the multiverse theory are vast. If our universe is one of many, it would challenge everything we know about our place in the cosmos. It would mean that the universe is far more complex and interconnected than we ever imagined, and that there are likely other versions of ourselves, other forms of life, and entirely different versions of the cosmos, each unfolding with its own set of rules. The potential for humanity to interact with other universes, if the multiverse theory holds, is a tantalizing idea. The boundaries between universes might not be as rigid as we once thought. If the disturbance is the result of a multiversal interaction, it could signal that the barriers separating universes are more porous than we realized. Could this be the first step toward exploring alternate dimensions, or even making contact with other forms of life from parallel realities? While the multiverse hypothesis remains speculative, it is gaining traction as more data from the disturbance is analyzed. The possibility that the universe is not an isolated entity, but part of a vast multiverse, has profound implications for the future of science and space exploration. If this theory is correct, humanity may not just be exploring the edges of our own universe, but standing on the cusp of discovering the true nature of reality itself. Researchers continue to explore the connection between the disturbance and the multiverse using advanced simulations, theoretical models, and cutting-edge observational tools. Although answers may not come quickly, the search for understanding is shaping the future of cosmology and physics in ways we cannot yet imagine. As we unravel the mysteries of the disturbance and its potential links to the multiverse, humanity stands at the threshold of a new era of discovery. The universe is no longer the isolated, self-contained entity it once appeared to be. It is part of something much larger, more interconnected, and more mysterious than we ever thought possible. Stay with us as we delve deeper into the possibility of the multiverse and what it means for the future of our universe. The answers are out there, and they may hold the key to unlocking the greatest mysteries of existence itself. As the disturbance ripples through the cosmos, one central question remains: how should humanity respond to this cosmic upheaval? The universe, once thought to be a stable backdrop, is proving itself more dynamic and unpredictable. Whether this disturbance signals cosmic collapse or the dawn of a new cycle, it forces us to reconsider our place in the universe. The immediate challenge for scientists is to monitor the disturbance and gather data. Space agencies like NASA and ESA are tracking the event and its effects on space-time. Current tools are being stretched to their limits, as this disturbance is unlike anything humanity has encountered. Researchers rely on advanced technologies such as space telescopes, gravitational wave detectors, and quantum simulations. The next few years will be crucial in determining if this event is a precursor to collapse or part of a grander cosmic cycle, but data alone won't provide all the answers. As humanity faces the possibility of profound changes in the universe, we must also grapple with how to prepare for the unknown. If the laws of physics are shifting, everything we know about the cosmos may no longer be reliable. The future is no longer just about scientific discovery. It's about adapting to a universe in flux, one that might not operate by the rules we once thought immutable. The path forward requires adaptability and collaboration. The disturbance shows that no single nation or institution can tackle this alone. The future of space exploration and humanity's survival may depend on a global effort. Theories once speculative, like quantum gravity and dark matter interactions, are now at the forefront. Governments, institutions, and private companies will need to collaborate to gather data, refine models, and create strategies for whatever lies ahead. But what does this mean for humanity? The disturbance may seem like a scientific issue, but its potential consequences could profoundly affect life on Earth. Could the disturbance disrupt Earth's orbit or affect our climate? Could cosmic events amplified by the disturbance lead to unforeseen natural phenomena here? While there is no immediate evidence suggesting direct impact on Earth, the uncertainty is sparking new discussions about space preparedness. Governments are considering long-term plans for humanity's future. Could we one day need to leave Earth in search of a new home on another planet? While this may seem distant, the disturbance reminds us that we cannot ignore the long-term implications of our place in the universe. At the same time, this disturbance could present an unprecedented opportunity for scientific discovery. If it signals a new cosmic cycle or quantum shift, humanity could gain access to knowledge previously beyond reach. Imagine a future where space-time, dark matter, and quantum mechanics are fully understood, where we could manipulate these forces to our benefit. The disturbance also raises philosophical questions. The age-old questions about our place in the cosmos and our role in existence are being raised anew. As we confront the universe's uncertainty, it becomes clear that our understanding of life on Earth is intertwined with the cosmos itself. We are no longer isolated from the universe. We are part of it. The very fabric of the universe that governs our lives is being altered, driving humanity to rethink its priorities. Cosmic resilience will likely become a key focus. As we learn more about the universe, humanity will need to develop strategies for surviving in a more volatile universe. From space exploration to protecting life on Earth, the future will demand resilience in the face of cosmic challenges. Humanity's ability to adapt will determine our future in the cosmos. As we continue to monitor the disturbance and its far-reaching effects, the need for action is clear. We cannot afford to wait passively and hope the chaos subsides. Whether this event signals the end of the universe or the beginning of a new era, it is forcing humanity to confront the unknown. Through collective efforts, our willingness to explore, adapt, and collaborate, we will find the answers that will define our place in the universe. The journey ahead will not be easy, but it is one we must undertake. The disturbance is not just a cosmic event, it is a call to action. As we stand on the precipice of a new era in understanding space, time, and reality, we must be ready to face whatever lies ahead, together. The universe is changing, and humanity's response will shape our destiny in the cosmos. Stay with us as we continue to explore the unfolding mysteries of the cosmic disturbance. The universe is full of untapped potential, and humanity's role in this story has just begun. As humanity grapples with the existential questions raised by the disturbance, it becomes clear that the future of space exploration, survival, and understanding will depend heavily on technological advancement. The scale and complexity of the event, one that challenges the stability of spacetime itself, underscores the importance of innovation in our quest to navigate the cosmos. At the forefront of this technological revolution are space-based observatories and telescopes. Atlas, which first detected the disturbance, has proven invaluable, pushing the boundaries of our understanding of distant galaxies. However, the evolving disturbance demands more advanced instruments. Next-generation space telescopes, capable of observing a broader range of electromagnetic wavelengths, will be crucial in gathering more data. Telescopes like the James Webb Space Telescope, which has revolutionized our understanding of the universe, could offer critical insights into the disturbance's effects on space-time. Yet, even advanced telescopes have their limits. To truly understand the disturbance's impact, scientists must combine data from multiple instruments, including gravitational wave detectors like LIGO and Virgo, capable of detecting subtle ripples in space-time. The key to understanding the disturbance lies in measuring space-time itself, tracking subtle fluctuations that ripple through the cosmos. As physicists explore the relationship between dark matter, dark energy, and space-time, they will rely on cutting-edge computational models and simulations to recreate the conditions of the universe during and after the disturbance. Advancements in quantum computing will also play a significant role in our understanding. Quantum computers could process vast amounts of data in real time, enabling researchers to run complex models of space-time and quantum fields. This leap could unlock insights into the universe on both cosmic and quantum scales. Moreover, the development of technologies to monitor and potentially manipulate spacetime itself could become essential. Concepts like warp drives and wormholes, once speculative, may push the boundaries of science fiction into science fact. If we are witnessing the destabilization of spacetime, humanity could one day develop technologies to stabilize or navigate these shifts, revolutionizing space travel. The disturbance, whether it signals the collapse of the universe or a new beginning, has highlighted the need for humanity to prepare for a universe far more volatile than we once imagined. Space exploration is no longer a passive endeavor. The ability to adapt to cosmic shifts and harness new technologies will determine whether humanity can survive and thrive in an ever-changing universe. The impact of these technologies extends beyond the scientific community. If humanity is to face the challenges posed by this cosmic disturbance, The world must work together to develop and deploy the tools necessary to understand and adapt. Space exploration, once seen as a distant goal, is now vital for our long-term survival. Whether monitoring the disturbance, exploring new frontiers, or protecting our planet from cosmic threats, international cooperation is crucial. The potential breakthroughs in technology also raise ethical questions. As humanity moves toward the ability to manipulate space-time, what are the moral implications? Who controls the knowledge and technology to navigate the cosmos, and how do we ensure it is used responsibly? These questions must be addressed as we continue our journey into the unknown, emphasizing the need for global dialogue on technology's role in shaping the universe's future. Despite the uncertainty the disturbance brings, it is a time of opportunity. Humanity has the chance to push the boundaries of knowledge and technology, exploring the universe in ways that were once unthinkable. Whether the disturbance leads to the end of the universe or a new era, it forces humanity to reconsider its place in the cosmos. The path forward may be difficult, but it offers untapped potential, promising discovery, survival, and growth amid cosmic chaos. Stay with us as we continue to explore how technology shapes humanity's future in the cosmos. The universe is changing, and tomorrow's technological innovations may hold the key to understanding, navigating, and even mastering the forces that govern space and time. The journey ahead may be long, but with each discovery, we are moving closer to understanding the universe and our place within it. As humanity faces the cosmic disturbance that threatens to reshape the universe, we must ask, how far should we go in our response? The very nature of our exploration, discovery, and potential intervention in the universe is now in question. The disturbance calls into focus an ethical dilemma. How far should we push the boundaries of space exploration, quantum mechanics, and space-time manipulation? For centuries, humanity has looked to the stars as a symbol of aspiration and curiosity. However, with the disturbance unfolding before us, we are faced with a new reality. The universe is not passive. It is a dynamic, interconnected system that can be influenced by our actions in ways we may not predict or control. One of the most pressing ethical concerns is the possibility of tampering with space-time or other cosmic forces. If the laws of physics are shifting, as they appear to be, the potential to manipulate these forces could be within our reach. Could humanity, with the right technology, alter the course of the disturbance? Could we stabilize the fabric of space-time or control the behavior of galaxies, stars, or black holes? If such abilities are possible, we would face a profound responsibility to wield that power wisely. The temptation to fix the universe's instability may be strong, but what would be the consequences of such intervention? How can we ensure that our efforts to protect ourselves don't inadvertently create greater harm for other civilizations or disrupt the natural course of cosmic evolution? These ethical questions surrounding space-time manipulation are complex and will grow more pressing as our technological capabilities expand. Another ethical dilemma concerns space colonization. As the disturbance unfolds, it is conceivable that humanity may look to the stars for a new home. The possibility of establishing colonies on distant planets or moons has long intrigued the scientific community. But as we consider venturing into space, we must ask, what responsibility do we have to the ecosystems of other worlds? Should we colonize new planets to secure our survival, or should we respect the natural environments of other celestial bodies? Moreover, how do we balance exploration with the ethical consideration of preserving the unknown? The universe is vast and many parts of it remain unexplored. If humanity ventures beyond Earth, how do we ensure that we do so in a way that does not harm undiscovered life forms or ecosystems? The ethical implications of interstellar colonization are deeply intertwined with environmental stewardship, biodiversity, and the preservation of the unknown. At the same time, we must also consider the ethics of our response to the disturbance itself. While scientists and space agencies work to understand the disturbance and its potential effects, we must ask whether we have the right to intervene at all. Should we allow the universe to evolve on its own, or should we actively shape its outcome? Some might argue humanity has a duty to protect itself, while others may contend we must respect the inherent unpredictability and chaos of the universe. Finally, there is the question of how we ensure that the pursuit of cosmic knowledge and exploration remains a collective effort. The ability to manipulate space-time or colonize new worlds must not be left in the hands of a few powerful individuals or nations. The decisions we make now will shape not only our future, but the future of all life in the cosmos. It is essential that humanity as a whole comes together to discuss and address the ethical challenges posed by these new frontiers. This collective responsibility is not just about preventing harm, it is about understanding our role as stewards of the universe. As we venture deeper into space and unlock the secrets of the cosmos, we must do so with humility and respect for the unknown. The disturbance is a reminder that the universe is far more complex, unpredictable, and interconnected than we ever imagined. Our actions could have far-reaching consequences, and it is our ethical duty to approach these challenges with caution, respect, and a commitment to the greater good. As we continue to monitor the disturbance and explore its implications, humanity must ask itself, what kind of future do we want to create in the universe? The ethical decisions we make today will determine the path forward, shaping the future of space exploration and our place in the larger fabric of existence. Stay with us as we continue to explore the intersection of technology, ethics, and cosmic exploration. The disturbance is not just a scientific phenomenon, it is a challenge for humanity to confront its future in the universe with wisdom, responsibility, and a deep sense of shared moral duty. Our choices will define the legacy we leave for the cosmos. As the cosmic disturbance stretches across space-time, humanity faces a critical juncture. The future of the universe, and humanity's place in it, is no longer speculative, but a question of survival. The disturbance has thrust us into uncharted territory, forcing us to confront not only immediate challenges, but also the long-term consequences of living in a universe that is no longer stable or predictable. Given the scope of the disruption, humanity must act swiftly to prepare for potential outcomes. The uncertainty surrounding the disturbance, whether it signals the end of the universe or a cosmic rebirth, leaves us with few certainties. This uncertainty demands that we proactively develop strategies for survival. One of the key areas of preparation is technological resilience. The disturbance signals that the laws of space, time, and energy can shift unpredictably. Humanity's ability to adapt will depend on technological advancements. The first priority should be the development of advanced monitoring systems to track the disturbance in real time, providing clearer insights into its progression and impact on space-time. Moreover, humanity must invest in technologies to mitigate the effects of space-time instability. The potential for black holes to destabilize or galaxies to collide means we must be prepared to intervene. Though space-time manipulation sounds like science fiction, many technologies once thought impossible, from satellite communications to advanced medical treatments, are now integral to our lives. With the right focus and innovation, humanity could develop tools capable of controlling or withstanding space-time anomalies. Space exploration, traditionally a domain for scientific discovery, will also be crucial. As the disturbance spreads, it could affect regions of space beyond the Milky Way. Traveling to other star systems or galaxies may not only be possible but essential for humanity's survival. Establishing self-sustaining colonies on distant planets or moons could ensure a future for humanity should Earth become uninhabitable. However, space colonization raises essential questions. Where should we go? Which planets could support human life, and what will it take to make them habitable? Space agencies are already conducting research into planetary habitability, resource management, and the technologies required for long-term space travel. Colonization, while vital, presents ethical, environmental, and logistical challenges that must be addressed to ensure humanity's success beyond Earth. At the same time, humanity must focus on strengthening resilience here on Earth. The disturbance's long-term effects on Earth remain uncertain, but it could alter our climate, increase seismic activity, or bring other environmental changes. While these outcomes are speculative, the potential for disruption calls for renewed efforts in environmental sustainability, disaster preparedness, and resource management. Addressing climate change, preserving biodiversity, and developing renewable energy sources will be even more critical. Though the disturbance could destabilize the universe, humanity's ability to protect life on Earth will determine our survival. Strengthening ecosystems, building sustainable cities, and investing in regenerative technologies will ensure Earth remains a viable home for humanity, even as we explore the cosmos. Education and global cooperation will be key to preparing for the unknown. As the disturbance challenges our understanding of space-time and physics, The next generation of scientists, engineers, and thinkers must be ready to confront these profound challenges. Fostering curiosity, collaboration, and innovation will ensure humanity is equipped to face the unknown future. This includes advancing technological capabilities while promoting critical thinking, ethical responsibility, and a deep understanding of our place in the universe. The global community must also unite to tackle the shared risks posed by the disturbance. The scale of this event requires collective action. We cannot face the unknown future alone. Global cooperation will be essential to pool resources, share knowledge, and develop strategies for survival. The disturbance reminds us that we are interconnected, and our survival depends on our ability to work together across borders and disciplines. As humanity confronts the uncertainty of the cosmos, one thing remains clear. Our response to the disturbance will shape the future of our species and the universe itself. Whether the disturbance marks the end of the universe or the beginning of a new cosmic era, it forces us to reconsider everything we thought we knew about existence. The unknown is now more urgent than ever, but it also presents an opportunity to innovate, evolve, and transcend our current limits. The journey ahead will not be easy. The questions we face are monumental, but the disturbance is also a call to action. It reminds us that the universe is vast, unpredictable, and full of potential. Humanity's future in the cosmos is uncertain, but our ability to adapt, face the unknown, and chart a course for survival will define the legacy we leave for future generations. Stay with us as we continue to monitor the cosmic disturbance, exploring its ongoing implications and preparing for the unknown. Humanity's place in the universe is still to be determined. The answers to the greatest mysteries of existence may be just beyond our reach, but with determination, innovation, and global collaboration, we can unlock the potential for a new chapter in the story of the cosmos. As the disturbance unfolds, scientists and thinkers across the globe are realizing that the foundations of our understanding of the universe may need to be rewritten. The constants of nature, the stability of space-time, and the predictability of cosmic events are now being questioned. If the disturbance signals larger universal instability, the laws of physics that have guided us for centuries could be undergoing a fundamental transformation. This raises a profound question. What new foundations must humanity establish to navigate a universe that is no longer predictable? The first step in this new era of scientific inquiry is rethinking the laws of physics. The disturbance is not a random event, but a sign of underlying forces at play, forces we're only beginning to understand. The shift in space-time we're observing could indicate that the universe is transitioning into a new phase of existence, one where the old laws no longer apply. Our understanding of gravity, light, and time may be fundamentally altered. For instance, gravity, once thought to be a constant force, may fluctuate as space-time itself warps in response to the disturbance. One area where these changes could manifest is in the interaction between quantum mechanics and general relativity. For years, scientists have struggled to reconcile these two pillars of physics. The disturbance may be the first evidence that these realms are more interconnected than previously thought. Quantum phenomena might influence the large-scale behavior of space-time itself. To understand these interconnections, scientists will need to develop new theories that bridge quantum mechanics and relativity. One potential avenue of research is quantum gravity, which seeks to describe gravity on the smallest scales. If the disturbance is influencing space-time, it could provide crucial clues to unraveling quantum gravity. Beyond gravity, other fundamental forces could also be affected. Electromagnetism and the nuclear forces, which govern matter, may experience shifts as the disturbance spreads. Understanding these changes could lead to groundbreaking discoveries in particle physics, unveiling new particles, forces, or dimensions that were previously beyond our reach. These discoveries could change how we interact with the universe, opening up possibilities for technologies like energy manipulation or faster-than-light travel. The disturbance also challenges our understanding of space-time itself. Traditionally, space and time were viewed as a continuous fabric, with gravity bending this fabric in the presence of massive objects. However, if the disturbance is causing fluctuations in space-time, we may need to rethink this view. Space-time could be discrete, much like quantum particles, leading to a deeper understanding of the universe at its most fundamental level. As we search for new foundations in physics, we must also reconsider our philosophical approach to the universe. For centuries, humanity has operated under the assumption that the universe is governed by fixed laws. The disturbance is showing us that the universe is far more dynamic and unpredictable than we imagined. Space, time, and matter are in flux. This realization forces us to ask deeper questions about our place in the cosmos. If the universe is constantly evolving and changing, what does that mean for humanity? Are we simply at the mercy of cosmic forces, or can we influence the course of the universe? If the laws of physics are not fixed but subject to change, can we actively shape the future of space-time? The disturbance could hold the key to unlocking new possibilities for humanity, both scientifically and philosophically. In the coming decades, humanity will need to embark on an intellectual and technological journey unlike any before. We will need to forge new scientific frameworks, challenge our assumptions, and develop new technologies to navigate a reality more uncertain and chaotic than we ever imagined. This will require collaboration across disciplines, from physics and engineering to philosophy and ethics, to chart a course for the future. As we face this unknown future, one thing is certain: the disturbance is forcing humanity to evolve. Our current understanding of the universe is no longer sufficient to explain the unfolding events, but this crisis also presents an unprecedented opportunity. The disturbance could lead us to a deeper understanding of the cosmos, one that transcends our current knowledge and opens new realms of possibility. By embracing this challenge, humanity has the potential to unlock the greatest mysteries of existence, revealing a universe more complex, dynamic, and interconnected than we ever imagined. Stay with us as we continue to explore the unknown. The disturbance is not just a cosmic event, it is a catalyst for change, a sign that humanity must adapt, innovate, and rethink everything we know about the universe. The future is uncertain, but through our collective efforts, we will shape the next chapter of our existence in the cosmos. As humanity stands on the precipice of a new era in the cosmos, defined by uncertainty and the unfolding cosmic disturbance, an essential question arises: what is the role of the human spirit in a universe that may no longer be stable or predictable? In the face of profound cosmic changes, how do we, as a species, define our purpose and place in the universe? The disturbance, with its vast impact on space-time and our understanding of the physical world, has shaken the foundations of science, philosophy, and human existence. But in the face of this upheaval, humanity's response is not just scientific, it is deeply philosophical. This event, far from signaling our demise, opens a door to a new chapter in human history, one that tests our resilience, creativity, and capacity to adapt to the unknown. Throughout history, humanity has faced immense challenges, from natural disasters to global conflicts. Yet, time and time again, we have found ways to adapt, innovate, and rise above. The quest for knowledge and determination to face adversity have defined us as a species. Now, we must draw upon that same resilience to meet the challenge head-on. The disturbance challenges us to expand our conception of what it means to be a part of the cosmos. For centuries, humans have viewed themselves as central figures in a vast but ultimately understandable universe. The disturbance reminds us that the universe is far larger and more unpredictable than we ever imagined. In this new reality, humanity must look inward, reflecting on our values, place in the universe, and responsibility to each other and the world we inhabit. The disturbance has the potential to disrupt not only the fabric of space-time, but also the way we live, work, and interact. The technologies we develop, discoveries we make, and ethical choices we face in the coming years will shape the legacy we leave for future generations. Global collaboration will be essential. The response to this crisis will not be just a scientific endeavour. It will require the combined efforts of governments, institutions, and individuals worldwide. If we are to adapt and thrive, we must share knowledge, resources, and expertise. We must approach the unknown not as isolated nations, but as a united species, recognizing our shared fate in the vast cosmos. The disturbance is a cosmic event unlike any other, but it is also a symbol of growth and transformation. It reminds us that the universe is alive, constantly evolving, and full of infinite possibilities. In the face of uncertainty, humanity has the power to shape its future, to explore new frontiers, understand the deepest mysteries of existence, and find meaning in the vast cosmos. As we move forward, humanity's greatest strength will not lie in technological advancements alone, but in our ability to adapt, unite, and embrace the unknown with courage and hope. The disturbance may be a sign of cosmic upheaval, but it is also an invitation to a new beginning, one that calls on us to rise to the challenge and redefine what it means to be human in a universe still unfolding before us. Stay with us as we continue to navigate the cosmic disturbance, exploring the unknown and seeking answers to the profound questions it has raised. The future of humanity and the cosmos is still to be written, and through our collective effort and spirit of discovery, we will determine what comes next. The journey ahead is uncertain, but the possibilities are limitless. Together, we will chart a course for the future, defined not by the disturbance, but by the strength, resilience, and hope of the human spirit. As humanity stands at the threshold of a new cosmic era, the question is no longer whether we can adapt to the disturbance unfolding across the universe, but how we can harness the power of this unprecedented event to propel ourselves toward new discoveries and achievements. The cosmic upheaval has already begun to push the boundaries of our scientific knowledge, and with every new finding, the potential for groundbreaking discoveries expands exponentially. What if, instead of being a harbinger of destruction, the disturbance is a catalyst for unlocking mysteries of the universe that have been hidden for eons? The disturbance is already revealing new layers of the cosmos that were previously beyond our reach. Space-time, once thought to be a rigid, unchanging framework, is now showing signs of flux. This revelation could lead to a shift in how we view the very fabric of reality. As we delve deeper into the disturbance, humanity may uncover new laws of physics, new dimensions, and new forms of energy that were once theoretical. One exciting possibility is the potential for new forms of matter. Just as quantum physics has shown us that matter at the smallest scales behaves in ways that defy classical intuition, the disturbance may lead us to discover entirely new types of matter, substances in states we have yet to imagine. These new forms could change our understanding of chemistry, physics, and even biology. Moreover, the disturbance may allow scientists to explore the concept of parallel universes or alternate dimensions. The idea that our universe is part of a larger multiverse is gaining traction as new data is analysed. If the disturbance is a result of a cosmic interaction between universes, humanity could make contact with alternate realities. This breakthrough could lead to the discovery of parallel versions of Earth, possibly inhabited by versions of ourselves. In addition to exploring new realms of matter and dimensions, the disturbance offers an unprecedented opportunity to study space-time itself. If it destabilizes the fabric of space-time, it may provide the tools to manipulate space itself. Theoretical concepts like warp drives and wormholes could become tangible technologies. If we understand how the disturbance interacts with space-time, we might develop methods for faster-than-light travel, opening up the universe for exploration. The disturbance has also prompted us to reconsider the very nature of life. If the laws of physics are changing and space-time is altered, what does that mean for life beyond Earth? Could the disturbance be the catalyst for the creation of new forms of life? Could we be on the brink of discovering extraterrestrial life, or forms of intelligence that have evolved under completely different physical laws? In the face of these possibilities, humanity must maintain its sense of curiosity, exploration, and adaptability. The disturbance is not a challenge to be feared, but an opportunity to expand the horizons of what is possible. The unknowns it presents may seem overwhelming, but they are invitations to explore, to learn, and to grow. If we approach this cosmic upheaval with the same spirit of discovery that has driven us throughout history, we will find that the disturbance is not the end, but the beginning of a new chapter in our understanding of reality. As we venture further into this new era of cosmic exploration, the tools of the future will be collaboration, innovation, and imagination. The scientific advancements we make will not only transform our understanding of the universe, but will have profound implications for humanity. The discoveries we make, the technologies we develop, and the philosophical questions we confront will shape our existence and our place in the cosmos. The disturbance is a cosmic challenge, but also an invitation to push the boundaries of knowledge, to explore the unknown, and to redefine our role in the universe. The answers to the mysteries ahead may be more profound than we can imagine, but they are within our grasp. As we unravel the fabric of space-time, we will uncover not only the deepest secrets of the cosmos, but also more about ourselves. Stay with us as we continue to explore the endless possibilities that await us. The disturbance is not just a scientific event, it is a call to adventure, to discovery, and to the realization that the universe is far more dynamic, complex, and full of potential than we ever believed. Together, we will navigate this unknown frontier, unlocking the secrets of the cosmos one discovery at a time.